Hey, geometry class, and welcome back. As we finish out the week, we're going to just kind of review again the concepts that we've talked about this week, take them maybe a little bit further, but this first question hopefully seems like mostly reviewed to you. So the first thing we're going to do is establish, do we know the relationship here? So they are on the outside, so that's exterior, and one's on each side of the transversal here, so that's alternate exterior. And hopefully by now you know that alternate exterior angles are congruent. So we know they're the same or they're equal. So 4x plus 3 will equal 2x plus 51. Okay, now we're going to solve this. So subtract the 3. And then subtract 2x. We get 2x equals 48. And we know then that x equals 24. Now for this problem, all we had to do was solve for x. But if they asked us what this angle is, all you would have to do is plug it in right there for the x. So 2 times 24 is 48, plus 51 gives us 99. You also, if you'd preferred, could have plugged it in there. 4 times 24 gives us 96, plus 3 is also 99, which makes sense because those angles are equal. All right, our next one. Now this one's a little bit more challenging because we don't have a name to describe these two angles compared to each other. However, this angle right here and this angle, the two with the blue dots, those are what we call corresponding angles. And we know that corresponding angles are equal. So that means I can rewrite this up here. They're congruent, they're equal, they're the same. So now, hopefully you can see the relationship here where I'm putting the red dots. These ones do have a name that we can call it. That is what we know as a linear pair. And linear pairs are supplementary, meaning 3x plus 5 plus 5x plus 7. Supplementary means they add up to 180. So let's combine our like terms. The 3x and the 5x gives us 8x. 5 and the 7 gives us 12. Subtract the 12, we get 8x equals 168. And at this point divide and we get x equals 21. All right, on to the next one. This problem. Notice here we don't have parallel lines anymore. For this one we need to examine that upside down T. It looks like this. That is what we call perpendicular. So hopefully you guys remember perpendicular. They intersect forming right angles. So if that is the case, we know that this is a 90-degree angle there. So that means these two angles here are going to be complementary. They're going to add up to 90. So 27 plus 5x plus 3, all of this will equal 90. Combine your like terms. 5x plus 30 equals 90. Subtract that over, 5x equals 60. Divide by 5 and we get x equals 12. And we would be done. All right, the final problem for this one says given that that line L is parallel to line M is parallel to N. So if these lines are parallel, they're parallel to all of them are parallel to one another. Okay, because think about if L is parallel to M, M is to N, kind of like the transitive property last chapter, we can cut out that middleman. We also know that L is parallel to N. So to solve this, we can do it one of two ways. First, we can think right here and here, these would be corresponding. So we know this is 6x plus 11. At this point now, these two are corresponding. So if that is the case, then I know they're equal. So 7x plus 3 would equal 6x plus 11. However, there's even one easier way we can do this. In my opinion, it's easier. And that is if these lines are parallel, we can just forget about this line. I'm going to kind of cut it out. I blacked it out. And now L and N are still parallel, which means this and this angle are corresponding. So if that's the case, we set them equal to each other. Now we solve it. Subtract the 6x over. We're left with X plus 3 equals 11. We subtract the 3 over. We have x equals 8. And we're done. That's all we have to do. So today, there is another Delta Math assignment. If you need help, please reach out to me. Remember, let's finish strong. Okay, we're almost to fall break, but you got to give me one more week. Let me know if you have any questions. Bye.